Hi everyone, my name is Yuni and today I'm excited to share my project, NailAI, a cloud-powered fine-grained nail disease detection system. This system takes a nail image from a user, analyzes it using deep learning and returns an explainable diagnosis, all deployed end-to-end on Google Cloud. The main goal of NailAI is to build a real production-like diagnostic pipeline. I wanted a system that accepts images from either file upload or from desktop camera, runs a hierarchical classification model, generates gradcam heat maps for explainability, and processes everything asynchronously using PubSub and Cloud Run workers. By the end, I was able to create a scalable cloud-hosted application that feels almost like a real medical AI product. My system provides three major capabilities. First one is hierarchical machine learning classification. It first predicts a coarse disease group and then routes the image into a specialized fine-grained classifier. It even includes a second opinion arbitration model for ambiguous cases like psoriasis and nail deformity. The second one, explainable AI. I use gradcam to generate heat maps so users can see which part of the nail the model focuses on. The last one is distributed cloud workflow. The architecture separates request handling from inference using PubSub. This allows the backend to stay responsive even under heavy load. For software, I use Python 3, PyTorch 2, Fast API, Tailwind CSS, and plain JavaScript for the front end. For cloud services, I use Cloud Run, which apply for backend and worker, and PubSub, cloud storage, BigQuery, plus cloud logging for debugging. Then I use local GPU workstation for training, Cloud Run serverless CPU for inference. This is a high-level architecture. Instead of running inference inside a single backend, I separate the system into a lightweight Cloud Run API service, a PubSub message queue, a dedicated inference worker, and storage plus analytics components. This gives the system scalability and a real production-like layout. Okay, let me work through each step with a bit more detail. The user uploads or captures a nail image and sends it to submit. The backend stores the image in cloud storage and publishes a message to PubSub. The worker receives that message, downloads the image, and runs the inference logic. The worker generates a heat map, writes it into storage, and logs everything into BigQuery. The front end pulls status job ID and updates the UI as soon as the results are ready. This asynchronous structure is how real-world machine learning services handle large workloads. For debugging, I relied heavily on cloud logging to trace backend requests, PubSub message flow, and the worker's inference logs. This helped me catch issues like missing model files, incorrect storage paths, and message decoding problems. I also debugged PubSub push delivery and fixed base64 envelope errors to make sure jobs never get dropped. Before deploying, I tested all routes locally using Fast API's test client to validate submit status and image preprocessing. For training, I used a two-stage hierarchical classifier with Resonate 18. I applied data augmentation, confidence routine, rejection thresholds, and gradcam explainability. This structure improved accuracy while keeping the model lightweight enough for Cloud Run. For testing, I validated the entire async pipeline end-to-end, from the front-end submission through PubSub, all the way to worker inference and BigQuery logging. I also performed simple load tests with concurrent submissions to confirm Cloud Run auto-scaling, and tested camera capture on multiple devices to ensure a smooth user experience. Now I'll demonstrate the website. Okay, on the home page, I can choose upload an image or switch to the camera tab. The camera version works on mobile as well and captures a cropped ROI of a single nail. Here, I'll upload a sample image. Okay, then let me choose one image. Here you are. And when I click predict, the image is uploaded, stored in cloud storage, and then queued as a PubSub job. Then the UI shows me a job ID and starts polling for progress. So we can see job is still processing, and we can see here the submit and response is the status is queued, and this response will be right into BigQuery. Okay, and when we wait for the result, we can see the BigQuery here and the nail bucket. The bucket, I store the heat maps images and the input images here. Okay, now as soon as the worker completes inference, the final results appears here. We can see the course disease category, the final fine grained prediction, the confidence scored, and the routing path it took inside the hierarchical model. And there's also a grad camp heat map that highlights the exact nail region the model relied on. Then I can choose visibility or open it in a new tab. So we can see the nail focus on this plot, so it predicts this nail is healthy. Okay, everything I just showed runs fully on Cloud Run asynchronously, and it scales automatically. And I also add a button about clear story button here, so it would not have privacy issue here because we can clear history, and there's no your data here. Okay, data. Okay, my current setup can handle multiple simultaneous users because PubSub absorbs bursts of traffic. Cloud Run automatically scales up the worker when many jobs arrive. But we also have potential bottlenecks include cold starts, delays for the worker service, PyTorch model load time, and BigQuery write latency. But the asynchronous design ensures users never need to wait for inference inside the request itself. To wrap up, I built a cloud-deployed medical AI system with hierarchical classification, explainability, asynchronous processing, and real-time camera integration. This project taught me a lot about combining machine learning with production-grade cloud architecture, and I'm really proud of the final result. Thank you for watching.